Okay guys, this is 8.5. We have one more section after this, 8.6, and I'm probably going to break that up into two sections, but this is 8.5. And before we begin, I need you to go back and find your unit circle. You are going to definitely need that for today. So if you want to hit pause, go grab it, or at least have it out and visual, you'll want to do that. So what we're going to be doing today is we are going to be evaluating trig functions based on the unit circle, and this is actually the lesson that I would have taught you guys on the day that we had the 8.1 through 8.4 quiz. It's a very short lesson and it's pretty simple. There's a couple little tricks to it, but for the most part it's pretty simple. So before I get into the actual lesson in the PowerPoint, on your trig table, I want you just to notice a couple of things about the trig table. First of all, remember we've talked about this before. You've got the degrees all the way around a circle is 360 degrees, but notice that each of the sections is broken up into 30 degree, 45, 60 degree increments, and so on and so forth. And if you're thinking, oh, those look familiar to me, they do. This is all based off of the 30, 60, 90, 45, 45, 90 right triangle. So imagine that this right here is a radius of 1. And if your hypotenuse is 1, remember the side opposite the 30 is half. The side opposite the 60 is that the square root of 2. And if you take a look, or it's not the square root of 2, excuse me, square root of 3. And so these numbers here are all coming from those special right triangles. So these come from the 30, 60, 90. This comes from the 45, 45, 90. And then notice that the numbers just start to repeat over and over and over again. So you have your degrees, you have your radians, and these are the coordinates on the unit circle. Now what I want you to write on your unit circle is the fact, if I can open my pen, there we go, is the fact that each of these coordinates has the x is what we call the cosine, and the y is the sine. Okay, so cosine, and then that would be of theta, being it could be 60, 45, 30, and your sine. So each of these, and this is like a coordinate grid, so your x's are your cosines, your y's are your sines, okay? So as an example, real quick example, the cosine of 30 would be the x coordinate of the 30 degree coordinate, which would be square root of 3 over 2. The cosine of pi over 6 would be square root of 3 over 2. So anytime I ask you for the cosine of something, you're going to be looking at your x coordinates. If I asked you for the sine of 30 degrees, you're going to be looking at your y coordinate. So the sine of 30 degrees is 1/2. The sine of pi over 6 would be 1/2. The sine of 45 would be square root of 2 over 2. And so as you can go along the unit circle, you can decide what the answer is. Now I said there was one small trick, and that's going to be tangent. The tangent of theta is going to be your y divided by your x. And we actually talked about that when we were doing the last section of 8.4. Remember how we figure out the tangent is to take the sine divided by the cosine, right? Or y divided by x. And so that's going to be your tangent, okay? Sorry, my dogs are barking in the background. All right, so let me give you just a quick example. So let's do the first page of the notes on 8.5. And the reason why I wanted you to have your big unit circle out is because I have it here, but it's pretty small. But maybe if you printed it out on a big piece, you would have it pretty big. But I'm going to actually refer to my unit circle just so we can see it a little bit better. But the first question is asking us for the sine of 60. And so if I want to know the sine of 60, then I'm going to go to my 60 degrees. And remember, sine is the y coordinate, square root of 3 over 2. Ha, that's your answer. How easy is that? Okay? How about the cosine of 11 pi over 6? And so I'm going to come over here and I'm going to find 11 pi over 6, which is right here. And by the way, these are all going to be on the unit circle, which makes it nice. And what did we want to know? We wanted to know the cosine. Remember, cosine is our x. So that would be simply square root of 3 over 2. Can you believe people would miss this? It's so easy, right? So easy. The tangent of 300, and so I'm going to come to 300, and the tangent, and notice that I have this coordinate here. Well, remember the tangent is y divided by x. Now I'm going to show you a really cool trick here. So it's going to be y divided by x, or negative square root of 3 over 2 divided by 1/2. And I'll actually work it out over here. So we have negative square root of 3 over 2 divided by 1/2. Now, how do we divide fractions like this? Remember, if you're dividing fractions, you're multiplying by the reciprocal. So if I take square root of 3 over 2, negative square root of 3 over 2, and I times that by the reciprocal, of 2 over 1, take a look at what's going to happen here. Your 2's are going to cancel, and you're left with just the negative square root of 3. But here's my little shortcut. Whenever your denominators match, they cancel out. So you just get negative square root of 3 over 1. And take a look at every single denominator that we have on the unit circle is a 2. So every time you have to find the tangent, you're going to be canceling out that denominator, and it's going to be just whatever the numerator is divided by the numerator. So that might make your life a little bit easier. So the answer to this one is just simply negative square root of 3. Last one. Now remember, what does a negative degree or radian mean? That just means to go the opposite direction. Remember, going around the unit circle, you're always looking at going counterclockwise. Well, negative, remember, means to go clockwise. Pi over 6 is 30 degrees, right? So instead of going up counterclockwise, I'm just going to go down clockwise 30 degrees, and I'm going to land on 330 degrees. And remember, I wanted the cosine of that. The cosine is going to be the square root of 3 over 2. Now in this particular case, hey, we would have got lucky if we didn't notice that negative, but it's not always going to be. So you do always want to make sure you go in the right direction. Square root of 3 over 2 is the answer to that one. Okay, and there you have it. So that's, I mean, how easy is that, right? Now, the last thing we're going to do, and there's only one more thing, as we're going to work backwards. Now, we're going to be given the coordinate, and we want to work backwards and figure out what the degree is. But see, here's the catch. If I said the cosine inverse of square root of 3 over 2, well, you have choices here, right? So how do you know which one it's going to be? And so that's going to take us into the domain of these trig functions. Now, sine inverse, remember when we were doing this back in 8.1, I said whenever you want to find a degree, or in this case a radian it could be, you're always going to use the sine inverse. When you're looking for an angle measure, you're looking for the inverse, or that's the button that you're going to be pushing. And the symbol that we used for sine inverse was sine to the negative 1. And so if you are calculating that, you are going to be, your answer will be some kind of a degree or a radian. But there's one more word or symbol that you're going to see that means the same thing, and that is called arcsine. So if you're asked to take the arcsine of something, that is the exact same thing as saying sine inverse. And the same thing with cosine. If I have the cosine inverse, I'm looking for a degree or radian. You might also have see it as arc cosine. Okay, that means the same thing. And then tangent, same thing. Tan inverse is the same thing as arctan. Now, each of these has a specific domain. If you are talking about sine, and you are asked to take the sine inverse, you must stay in quadrant 1 or 4. That is it. And the y-axis. That is it. So when you're looking at sine, sine will be quadrants 1 or 4 or the y-axis. You must stay in those two areas. You cannot go outside of that. If you're looking at the cosine inverse, you have to stay in quadrants 1 or 2 only, or the x-axis. So quadrant 1 or 2 or the x-axis. Oops, there we go. And last but not least, tangent looks a lot like sine. It's very, very close, but there's one difference. If you look closely at the y-axis, notice it's dashed. And remember, a dashed line is not included. So for tangent, you must stay in quadrant 1 or 4, and that is it. No axes, okay? Those are the domains of sine, cosine, and tangent. Now, why am I telling you this? Well, let me go to the next page, and I'll keep this handy. Okay, I'm gonna move my light up here. I'm gonna keep this handy as we go through these examples. Okay, so as an example, I want to find, on the very next slide, I want to find the sine inverse of square root of 2 over 2. Well, remember, sine is your y coordinate. Remember, sine is our y, right? So I'm going to find the square root of 2 over 2's in the y location. So here's one right here, okay? So that's square root of 2 over 2. And I have another one over here that is square root of 2 over 2. And down here I've got the negatives. I don't want those. I want a positive, right? Well, see, notice I've got a couple of choices here. Well, here's where your domain is going to come into play. Remember, for sine inverse, you must stay in quadrant 1 or 4. It says nothing about quadrant 2. Therefore, we do not want to go into quadrant 2, so therefore I must use this one right here. I want the sine inverse of square root of 2 over 2, and that is going to be either pi over 4 or 45. I'm going to write both answers. And that's your answer. Okay? That's it. How easy is that? Now, arc cosine of negative square root of 3 over 2. Remember, arc cosine is the same thing as cosine inverse. And remember, cosine is the same thing as x, right? So I want the arc cosine of negative square root of 3 over 2. Let me change colors here. So this one we'll do in red. So I'm going to find all the negative square root of 3 over 2's. So the negative square root of 3 over 2's, there's one right here. That's a negative square root of 3 over 2. And then we have another one down here. There's negative square root of 3 over 2. And these are positives on this side, right? So, because that's the positive x side. So that leaves me with these two choices here. I want to stay in the right domain with cosine. It has to be up here in quadrant 2. You cannot go down into quadrant 3. And so therefore my answer will be either 150 degrees or 5 pi over 6. What was it? 5 pi over 6. Okay, there you go. Now, tan inverse of square root of 3. Now, you remember, how did we get the tan? Remember, tangent came from, and I'm just grabbing another colored pen here. Tangent came from taking your y divided by your x, okay? So I had to have square root of 3 over 2. And so here's how I would look at it. I would look at it as this. That's what I have right there. Square root of 3 over 1. How did I get that? Well, if I want the square root of 3 over 1, the only way I got that was taking the square root of 3 over 2 divided by 1/2. Working backwards. Remember, the numerator, right? Now, what would result in a positive square root of 3? Well, that would result in a positive divided by a positive, but also it could be a negative divided by a negative. You have to think about that, right? So I'm going to look for, this is my y, this is my x. So I want to find the coordinates that say 1/2 square root of 3 over 2. That would be one choice. Or the negative of those, right? All right, so let's take a look at the unit circle. So 1/2 the square root of 3 over 2 in that order is right here. Negative 1/2, negative square root of 3 over 2 is down here. Okay, so those would be my two choices. Now remember, tangent, we have to stay in quadrants 1 or 4. Therefore, we know it's not going to be down here. It's got to be this one up here, which is going to be 60 degrees or pi over 3. So that one, a little tricky, but if you can remember my trick about numerator divided by numerator, that should get you. The only other thing I can tell you is that what if it was the opposite? If it was like square root of 3 over 3, that just meant that it was 1 over square root of 3 and it got rationalized. And I'll probably do one of the homework for like that. All right, last example on this one is the arc sine 0. So arc sine, remember sine is our y. We want the y coordinate of 0. So the y coordinate of 0, let's do a different color here. How about orange? The y coordinate of 0 is over here on this side, or we have a y coordinate of 0 on this side. Now remember, sine has this side here, so we know it has to be here on the right. Now, what's the answer? Well, there's a lot of answers. We could have 0 as an answer, 0 degrees. We could have 360 degrees as an answer. We could also have 2 pi as an answer. So it just depends. I would say it's probably one of these two, but 0 degrees means you just haven't gone around the circle yet, and it is possible that that is the answer as well. Okay? So that's working backwards, is you're looking at which coordinate are you using, what domain do I have to stay in, and that tells you what number or what on the unit circle to use. Now the last thing we're going to do, and I think I just have one more slide, and I think at least one of these, maybe 2 of them are on the homework, is what if you are asked to do more than one thing? So basically you're just going to work backwards from that. I'm going to get my unit circle out. You always want to work inside out. So here's how it works. You're always going to start by finding this, pretend that this isn't even here. And you're going to start by finding the cosine of 7 pi over 6. Now remember, that's not inverse. So that just means you're just going to go to pi over 6 and put your x coordinate there. That's what that means. So I'm going to go to my unit circle. I'm going to find 7 pi over 6, which is right here. And I want its cosine, so I want the x of that's negative square root of 3 over 2. So I'm going to have the sine inverse of negative square root of 3 over 2. Then we're going to go back up and do what we did up here on this slide here. Now we go to, okay, sine is y, right? So I need to find my y coordinates with negative square root of 3 over 2. So let's find my y coordinates that have a negative square root of 3 over 2. It's these two right here. But remember, sine has to stay in quadrants 1 and 4. So therefore, this is going to be my answer of 300 degrees or 5 pi over 3. Now, how do you know which is the answer? Here's how I do this. If my problem has a radian in it, then I'm going to end my answer as a radian. If my problem has a degree in it here, then I'm going to end my answer as a degree. So since this is a radian measure and it started in radians, I'm going to finish the problem in radians. And what was it? Negative square root of 3 over 2y. I'm going to put the answer as 5 pi over 3. And that would be your answer. Okay? All right, let's do this one. Now remember, ignore the outside. We're only going to look on the inside. So now we have the sine inverse of square root of 3 over 2. Sine again is our y. So I need to find my y coordinates with square root of 3 over 2 staying in the domain. So the y of positive square root of 3 over 2 was here and here. But remember, we want to stay in the sine domain, and so the sine domain. So I'm just going to say 60 degrees. You can choose one of these, but I'm just going to go with 60 degrees. So now I'm going to say the cosine of 60 degrees. I just replaced that, and now remember cosine is your x. So now I'm going to go back and go 60 degrees. What's the x? 1/2. And there you have it, guys. And that is 8.5.